Here we go with page 5, the stereochemistry page. We're going to look for chiral centers, first on prednisolone. And this guy, we're going to be looking for any four or for a carbon with 4 different groups. And by different, I mean any one little thing could be different, like a different branch chain. So we can rule out any carbons that are involved in double bonds because we know that they're not going to have 4 different groups. We can rule out any CH2 groups and any CH3 groups. So I'm going to add some notations and then remove it, but like none of these. Careful with I saw some X's that were confused with stars, so be careful with that. So those are the double bonds that can't be chiral centers. These are methyl groups, can't be chiral centers. These are all CH2 groups, so they could not possibly be chiral centers. Now, oxygen atoms also cannot be chiral because they always are going to have the 2-lone pair. All right, so then we'll clean these up. We're going to go one at a time. We see this carbon right here has a carbon that is secondary, a carbon that is tertiary involved in a double bond, a carbon that is tertiary not involved in a double bond, and a methyl group. Those are 4 different groups, even though they're immediately carbon. What's attached to those carbons immediately after that differs. So this is your first chiral center. Up here, this carbon is connected to a hydrogen that's not shown, a carbon that's connected to an oxygen, a tertiary carbon, and a quaternary carbon. So that has 4 different groups as well. This is your second chiral center. This carbon is attached to a hydrogen, a tertiary carbon, a secondary carbon, and another tertiary carbon. I hope you can agree that the 2 tertiary carbons are different because one is involved in a 5-membered ring and the other one is not. This is your third chiral center. This is connected to a hydrogen that's not shown, a secondary carbon, a tertiary carbon, and a quaternary carbon. So this is going to be another chiral center. Some of you may be wondering what tertiary quaternary meant. So real quick, if a carbon is connected to 4 specifically carbons, we would say it's quaternary. If a carbon is connected to 3 carbons, it's tertiary, and so on. Let's see, right here, this guy is connected to a hydrogen, an oxygen, a secondary carbon, and a tertiary carbon. So that's going to be another chiral center. This is connected to a carbon that's connected to an oxygen, a tertiary carbon, a secondary carbon, and a methyl group. That's another chiral center. This one is maybe the clearest of all, connected to an oxygen, a carbon of a carbonyl, a secondary carbon, and a quaternary carbon. These are 4 different groups. That's another chiral center. There should be 7 in prednisolone. 1, 2, 3, okay, 7. On biotin, we have 3 chiral centers. This one here is connected to a hydrogen, a carbon, a nitrogen, and a different carbon. This one is connected to a nitrogen. This one's connected to a sulfur, so they're quite different. That is a chiral center. For pretty much the same reason, this guy's a chiral center as well. It's connected to a nitrogen, a carbon, a hydrogen, and a different carbon. And last but not least, we have this one right here is a chiral center because it's connected to a sulfur, a carbon that is connected to a nitrogen, a carbon of a CH2 group, and a hydrogen. So that's that. Okay, so those are your chiral centers in biotin. So there was 10 total, 3 from biotin, 7 from prednisolone. The one below, we're going to assign RS configuration and then add on to that in part C, whether they're enantiomers or diastereomers using the RS configuration. First, this guy, we're going to prioritize. We have 4 different groups. There's a hydrogen that's pointing back, so this is the correct way to look at that chiral center. Nitrogen is going to be priority 1. This carbon is connected to an oxygen, so that's going to be priority 2. And then this methyl group is priority 3. It looks like R and actually is. So this is going to be an R center. Clean this up. Oops, that's not that. Okay, next we have a carbon with a hydrogen that's coming forward, so we're looking at it the wrong way, which we can deal with. We have oxygen's priority 1. This carbon is connected to a nitrogen, so it's going to be priority 2. These are carbons connected to just other carbons, that's priority 3. Looks like S, but because this 4th priority is sticking towards us, we're looking at it in the wrong way, so it looks like S, but is actually R. Next, we're going to use the same prioritization type rules. We can do these maybe a little bit faster. This one we're looking at again in the wrong way. 1, 2, priority 3. Looks like it's R, but is actually S because priority 4 is towards us. This one, priority 1, 2, because it's connected to oxygen. 3, we're looking at it the wrong way. Hydrogen's wedged. Looks like R is actually S. Next, we have priority 1, 2, 3. We're looking at it the wrong way because the hydrogen is coming towards us. Looks like 1, 2, 3, S, actually R. This one, hydrogen's coming forward. We're looking at it the wrong way. 1, 2, 3, looks like R, actually S. Next, 1, a 2, a 3. Looking at it in the right way. 1, 2, 3, looks like R, and it is. Finally, we have 1, a 2, a 3. Looking at it the wrong way. We can deal with that. Looks like R, 1, 2, 3, does a clockwise circle, but looks like R, actually S. So what we have is RR, SS, RS, RS. And once again, we're going to use that below to determine whether compounds are the same, or sorry, same wasn't an option actually, enantiomers or diastereomers. A and B, we have RR, SS. These are totally opposite. They're non-superimposable mirror images. This makes them enantiomers. A and C, we have RR and SS. One chiral center stayed the same, another one changed. These are diastereomers. B and D goes from SS to RS. So once again, diastereomers. So keep in mind that depending on which version of the exam you have, these letters might be written in different order. And finally, C and D is the one that got people probably the most because it looks like since they're both RS, they should be the same, but they actually weren't. And again, that wasn't an option. So if you kind of give these guys numbers and say, okay, well, the one that's closer to the arene ring or the oxygen is carbon 1, and the one that's closer to the nitrogen is carbon 2, then you can give it a 1s2r designation. So if you do that over here, the chiral center that's next to the oxygen is 1, and the chiral center that's next to the nitrogen is 2. You'll see that it actually is, they are different compounds. 1s2r versus 1r 2s means all the chiral centers changed, both of them. These are non-superimposable mirror images or enantiomers. Finally, we want to be able to draw a constitutional isomer of Sudafed. If you read the instructions up above, it said that Sudafed is the SS isomer, so it's this one. But really, the stereochemistry doesn't matter in terms of drawing a constitutional isomer because we just need to have the same molecular formula and a different connectivity. And the molecular formula was C10, H15, N, and O. If you look at the formula, or if you look at the structures rather, you'll see that there's 4 degrees of unsaturation, and that would be helpful for you in drawing the structure to make sure that you have 1 ring, 3 double bonds, and various other permutations of that. So one common thing that was great that I saw was just switching the position of the nitrogen, and oxygen was fine. So instead of having the oxygen closer to the ring, you could put the nitrogen closer to the ring, and you don't have to draw stereochemistry to be complete here. Another one, if you wanted to take the ring system totally out of it, but still have 4 degrees of unsaturation, you could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons, but you would still need to have 1, 2, 3, 4 degrees of unsaturation. Somewhere include that oxygen, and somewhere include that nitrogen. 10 carbons, 15 hydrogens, 1 nitrogen, and 1 oxygen. And that's the deal with constitutional isomers. Same number of atoms, different connectivity. It is not a three-dimensional, not only differing by the three-dimensional structure. So I hope that was helpful for you guys in understanding the stereochemistry page. I'll make page 6 as soon as I can.